students here. Okay, I just pick one of you. Yes. Okay, let's look at what we have here. Can we close the sidebar here? Ke tak? Ke tak boleh? Cannot Tak apa. Okay, this answer from Hazim. Let's check on his work. Okay, if you look at the question, it asks you to find what? Where's the question?
V1, V2, V3.
Okay, V1, V2, V3. Our aim is to find the unknown voltage node. So if you look at here, maybe I use red color. Okay. Usually, if the question asks you to use nodal analysis, you can see this thing clear, right? I hope so. And then what I will observe from your answer is, first, I'm going to check on your nodal analysis. Usually, the question will set the reference point. But if there is none, then the question also asks you to use nodal analysis. I will check on this part, the reference point. If you put a reference point 0, then there's a mark for this. And second, I will look at your node. The node you name it. So like this one, V1, yes. V2, yes. V3, yes. And then I will look at your current direction. This is all the step for nodal analysis, right? So you have that marks like this one, I2, I3, and IS. Okay, this is good. And this is why I say good, because you didn't name it as you wish. I know you put it as you wish. I1, I2, I3, yes. But sometimes you put this I3 is this one for Hazim's answer. Sometimes because this is happened to our my other section, he put the current direction going down. Yes, it's okay. Any direction is fine, but the name is IX. You know why this is wrong to put IX here in the middle? In the middle here. Can anyone answer that? Why we cannot put IX?
There's two IX on the other side there.
The other side is already IX. This one is your IX. So you cannot put other branch as your IX. So like what Hazim did here, this is good. I3. So he named this one as a I3. Okay. Now that's only for figure. So meaning to say, if you draw a figure with some information, I will give marks here. Usually like 1.5, depends on the total marks. And then I will look at the KCL. And please write down here, KCL at where? Like this, Hazim already done like note 1, note 2. This is good. But sometimes you just put KCL at note 1. So B1, something like this. And then what should you do next? Go to equation. So where is note 1? Note 1 is on your left side here. But before that, you need to identify a super node. Do you have a super node? How to figure out a super node or not? What should you look at? Oh, okay, Fahmi, sorry, because when I present something, they will stop accepting people in the Google Meet. So you guys need to be sharp on time. Okay, all right. Okay, next KCl at V1, but before that, you need to figure out a supernode. Do you have any supernode here? How to figure out a supernode?
An element in between
An element
two unknown
to unknown. What element?
source, node,
A voltage source, right?
a voltage source. Sorry.
A voltage source. Either this voltage source is an independent or dependent source. As long this is a voltage source, then this is in between two unknown nodes. Then you need to know that this is a super node. And any branch or element attached in parallel with this voltage source, then you also need to include this parallel element as one of the voltage source, super node. Okay. So since, do we have any voltage source here in the circuit?
No.
No, we don't have. So because of there's none, then there is no super node. Okay, please do not draw the boundary. But if there is, then you need to draw the boundary of your super node. And I will give marks there. Okay, number 1, KCl at V1. So you have how many junction here? Kejap Kami, this apps is actually, the name is Kami. So actually I want to highlight. Okay, highlight. This is branch number 1. This is branch number 2. And this is branch number 3. So in your equation, you need to have that 3 element. So this is number 1, number 2, and number 3. So I think Hazim's answer is correct. Because why? Because Hazim has all 3 components there. So, okay. Let me change the color to red. Okay. Now, entering current should be equal to leaving current. So you have enter the 3, right? Only 1. And then leaving IX and I1. Can you see this? Or is it too small? Do you know why I don't like people to use pencil? Because sometimes we cannot see it clearly. If you use pen, yes, I can see it clearly. But it's okay. I can still see this. But for you guys, I do not know. I hope you can see this. So I1, IX, and 3, right? So I1 plus IX equal to 3. This is what Hazin did. Okay, very good. And then you have a V1 minus V3 divided by 4. Why? Because this is V1 minus V3 divided by 4. How do you know which one to minus 2? So the current is entering the passive element 4 here. So obviously this is a positive and this part is negative. So the positive side is V1 minus with V3 divided by 4. That's why Hazim have this equation. This is correct. Next, you have V1 minus V2 divided by 2. Why? Because IX is entering passive element, should have here positive and negative this side. So that's why Hazim has this. Okay, and then do the simplify. Yes, I'm not sure the answer is correct or not. I just mark. Usually in my answer, I will check on your equation here. If you give me the correct answer, then I will give you like 1.5 straight away. I will not look at your this part because sometimes students make mistake here. Okay. Next, you have note number 2. Any questions so far?
No.
No, Alhamdulillah. Okay, now this one, the middle part, note number 2. Note number 2. You have 3, right? 3 branches. Let me mark this one as a branch. So branch here attached to V2 and branch here attached to V2 and also this one. So I mean to say you should have 3 element in your equation. Since Hazim has 3, Alhamdulillah, I think this is correct, but I need to look at the equation. So the first one, V1 minus V2 over 2. Yes, correct. This part. and then V2 minus V3, V2 minus V3 over 8. Why is this correct? Because the current is entering this side. This is I2. Should have a plus here and minus this side. And since this is IX, so IX is equal to I3 plus I2, right? This is KCL at this point. So you have for I2, you have V2 minus V3 divided by 8. That's why Hazim give this. And then you have a plus here. And then you have V2 minus 0 divided by 4. The last part. Okay, this is correct. So you have 1.5. And then maybe this is correct. I'm not sure. Okay, note number 3. Note number 3 is a little bit different, but don't be afraid. So look back. You have how many branch attached to V3? Can you figure out? 1 here already highlighted, and then 2. Anything attached, right? So you just look at that, and then you make sure you have all 3. So here you should have 2IX, yes, and then I1 plus I2 coming from where? This is I1, and then this is I2. Okay, good job. Okay, and then I1 plus I2 equal to 2IX. Why? Because this is your 2IX. Just follow the current direction here. So that's why Hazim give this answer. Yes, this is correct. By the way, if you give me this part, this one wrong, kalau katakan this is wrong, then I will look at your answer here. Okay? So meaning to say you will not get 1.5 lah. Maybe you will get like 0.5. But you still get it right because you have shown me some information. This is KCL, right? So you apply the Kirchhoff current law at this node. So I can still give you marks there. Okay, so for this part, V1 minus V3 divided by 4, yes. And then this one, just now. And then we have V2 minus V3 over 8. Yes, correct. This is this part. And then the third part, 2IX. But what is IX? What is IX? Tijab. IX is actually current flowing through 2 ohms here. So you need to know how to find IX. IX is equal to, look at here. This is V1, this is V2. And V1, the higher in polarity, should be minus with low in polarity, divide by 2. Because why? This is Ohm's law, voltage divided by resistor. So you should have this IX. And then you just apply in, substitute in this equation, and you can cross this part, and then you can reduce, and you will get some answer. Elimination technique. Sorry. By the way, if you I don't have answer, tapi we can check with your other friends. If you have things like this, you can put it in terms of, maybe you have your calculator, right? You don't need to show me all these steps. It's okay. It's fine. But if you find that this one is much better than use your calculator, and this is faster than using your calculator, then go ahead. You can write everything. It's good. But if you think that your calculator is much better than what you have mental prepared here, then you may proceed with your calculator. My concern is the last answer, this, all these 3. If you have it right, maybe this is 1.5. Okay. Do you have any question? This is also 1.5. Okay. Padam. Okay, padam. So if let's say you want to use matrices, you just rearrange this, you have V1, V2, and V3. And here 12, you have the second equation here, 0. And the third equation, 0. You have 2 minus 3 and 1. And you have number 1 here, 3 minus 2 and minus 1. Anyone have the same result as Hazim? Anyone?
Yes.
Yes, Alhamdulillah.
Yes, madam.
Yeah, very good. So Hazim answer is correct because all say that. Okay, can I save this one? Save or not? I hope it's safe and then I just return. You boleh return tak? Okay, done. Now go to mana ni? 14. Anyone here who already done the page number 12? Anyone? Anyone? Kalau siapa ada, even though you just draw the something very small, also can, no problem. Okay, we look at, if you have, please say so. Ni apa, sorry madam, try, okay, it's okay. Okay, if you look at your friend's answer here, okay, like I said, I will check your figure first. If you give me your figure, and that's marks on the figure. And then next, even though you put it something like this, and I will spend more time on figure out what you have here and also what you have here. And sometimes I will check juga at your, what is this at V1? Is it KCL or is it KVL? And then, yeah, if you give me this one right, I will give some marks, or wrong, it's wrong lah. Figure is very important because from that figure, I know that what you trying to show me here. Okay. Okay. So far, do you get me on the nodal analysis part? Anyone here with this page? Or do you have any question before we proceed to our next? This one. Do you have any? Before that, do you have any question on this?
No, we don't.
No, eh?
No,
Just put it in your mind. You can put any direction of your current, but you need to follow what? Follow passive sign convention. Please follow passive sign convention because everything depends on your passive sign convention regardless of your current direction. And then if you put it on maybe to the right or going down, just put it like that and don't change it. Depends on what you like. No, if you put it on your right side to going to the right, then put it as it is. Don't change. Okay, and then follow passive sign convention. Okay, anyone here with the answer for question slide 12, this part? Anyone? If you have, I will open your answer and then we can discuss on this because I want to look at your how you draw this and figure out your answer. Anyone? Tadi ada somebody want to say something? No?
Afi ada Afi.
Afi. Okay.
Because saya nak tanya how to do the if ada super node, but since madam nak explain dulu, I didn't have enough time to solve it, madam.
Right. Okay, tak apa. So anyone who submitted the second part here, or maybe just a little of your calculation. If you do have, maybe you can snap and then upload. If you found it hard to upload it in the Google Classroom, you just put it in your Telegram, the group. Anyone here? No? Kalau tak ada, then we go ahead with our answer here. Izzati?
I already submit for the practice on slide 12, but halfway, not
tak
complete
apa.
yet.
Okay, I will look at that. Sekejap. Mana? Izzati Mana Izzati? Oh, here. Right. Okay, here. Okay, we have this. Alhamdulillah. Okay. The question asks you to, let's say this is your question, Nah, this one, And obviously, there's no reference point, but you solve it using nodal analysis. So what should you do? First, like I said, we need to determine the essential node. So where is your essential node? Essential nodes is the one with the most branches, right? So you choose that as your reference point. So obviously this is number 1, number 2, number 3, number 4, and 5 branch, and all connected to down here. And you can put this as your reference point. Okay, so that's number 1 I'm going to see. Okay, number 1. And then I will look at your current direction. Since you have here, yes, very good. Very good. Yes and yes. Then this is your number 2. Number 3, I will look at your what we call this, the node value, right? So the node 1 here, let me give you this part is your 50, the 50 volt node. So let me write down, even though our sister Izzati already put some value here. Okay, this is 50 volt. And then the rest you need to name it, right? Because we don't have any voltage attached to this point and this point. Even though, yes, we do have at the middle here, the dependent source here, but why not we put this one, the V1 here, as your V delta divided by 5? Why not? Anyone can suggest something? Why not? Any suggestion? Dependent. Because this dependent source is not attached to the ground, right? If you put this one as a V1, yes, and then you do the calculation, V1, because V1 is higher in polarity, minus with low polarity, if this is attached to ground zero, reference point, and then equal to V delta divided by 5, then obviously V1 is equal to V delta divided by 5, and you can name this one as your V1. But since this is not attached to this reference point, where this one attached to? It's attached to V delta, right? So obviously we can cancel this equation. This one becomes V delta. This is V delta. So this one not the equation. It's actually V1 minus V delta equal to V delta divided by 5. But it's better not put into our note here. Just name it as simple as it is. So you just name V1 and V delta like this. So our sister here, she suggests V1 and V delta, which is very good. Why is it good? Because one of the reason, because if you look at your V delta here, it's already stated at this part, or you go back to your question here. Let me show you this part. It's already there. The information is there. So you use whatever they provide you. So mean to say the upper side here, it should be the node of V delta. Okay. And since 78 ohms and 39 ohms, both are in parallel, so you can actually combine it because both have the same node V delta up here. Okay. Any question? Or you can leave as it is like this, also can, no problem. Okay, good. Then, oops, I want to remove this part. Okay, now, I think most answer correct. Only this part missing. And then I will go to next step to find supernode. Do we have any supernode here?
Yes.
Yes. How do you know?
It's a voltage source in between two nodes.
Two unknown nodes. A voltage source, whether this is independent or dependent voltage source in between two unknown nodes. So because of that, you need to draw the boundary like our sister draw here. So let me highlight. This is your boundary. Okay, very good. Okay, next, when you have a supernode, what should you do? You're going to give what? Take out two things. What should you do? Apply. When you have a supernode.
KCL and KVL.
Yes, very good. KCL and KVL at the supernode. So let's see our sister answer. KCL. Okay. Before that, we look at how many. Yep. To change color. How many branches attached to this boundary of your supernode? So here, number 1, number 2, number 3, and number 4, right? So mean to say in your equation, you should have 4, at least 4 current entering or leaving the branches. So let's see our sister answer. We have current entering, which is I2. So this is I2. And the rest you have all leaving current. This is I3, I4, and I5. So yes, our sister's answer is correct. Number 1 correct. And then we look at this one is whether this is correct or not. So this is 50 minus V1 divided by 10, yes. And then V1 minus 0 divided by 30, yes. V delta over 39, V delta over 78. Yes, very good. So I will give you here 1.5 and here not 1.5 because you miss the 0 here, reference point. So you will get 1. And then the second part, this is what? This is KCL at super node. KCL at super node. So what is missing, or maybe she, yeah, because time's up, you need to have another one, KVL at supernode. So what is KVL at supernode? This part a little bit tricky, but it's easy. You just take out your voltage source. Like this one, a dependent voltage source, and then name the node. The two nodes, this is V1, this V delta, and the value of your dependent source, V delta divided by 5, right? So higher in polarity should be minus with low in polarity. This is higher and this is low. So V1 minus V delta equal to V delta divided by 5. So this is your second equation for your KVL at supernode. Is it clear? Is it clear or not?
Yes, ma'am.
Okay, alhamdulillah. So you have to simplify this part and simplify this part. But what is V delta? Ke ada? Ke tak payah? Tak payah. Tak payah. Because we have two unknowns here. And this one also two unknowns, V delta and V1 here. So you can use quadratic form or matrices form and you will get the answer, inshallah. Okay, I will not give you the answer, but the step is like that. You can compare with your friends and you know that your answer is correct or not. So since you have all information, you can solve for V1 and V delta. Clear? Alhamdulillah. Any question? Maybe you still don't get on the KBL part of Supernode or KCL. Which one you still confused? I think our sister here, she tried to do this combination of both. Yes, this is equivalent. Very good. If you simplify like this, you will simplify the steps. Meaning to say, in your equation here, we reduce from 4 to 3 only. So only 3 branches attached to the supernode. You can redraw back your figure, and then you will get as what you have like this are equivalent. Okay, any question? Or do you have any other question that you like me or all of us to solve during the class? Brothers and sisters, ke dah tidur dah?
Ada.
Okay. So if you look at the slide, Madani, the steps, I think this is the answer. 25.2, you can try. Because even though I said we have, this is V delta, right? And this is V1, but you going to find a value of interest. Yeah, in order to find V delta, you need to find V1 also. So that's why you have this. Okay, what about this one? Okay, let's see. Do you have any supernode?
Madam, if it's connected to the essential node, does it count as a super node or not?
Is it a value or no value?
So
Is
zero. So it's not counted as a super node.
Because why? Because the value of this part is a
Zero.
yes. And what about this part? The other one. This part.
It's 144 watts.
144. Yes, very good. 144. And the rest you can just name according to whatever information you have here. Like this one V1 and this one V2, right? So since they are in parallel to 3 amps and 5 ohms here, so you have a V2 node here. I think this one you can solve it, no problem. Very straightforward. But there's other way to solve this. We call it as a mesh analysis. So mesh analysis, we're going to discuss it in our next class, inshallah. Any question, or we can stop our class because in another 3 more minutes, or you want me to do something? We return to Izzati. Or any one of you here who already done that part, maybe I can just have a look.
Madam.
Yes.
Why I got the answer is negative 25.2.
Did you submit here or not?
No. Can I submit in Telegram, madam?
Okay.
Okay, madam.
Maybe the calculation or something.
Wait, then I will submit it.
Okay. Snap your answer and then upload. By the way, brothers and sisters, I think sisters are still okay. Brothers, because we know that there's COVID case, right? You just take care of yourself and try your best to use mask and wash your hands. Sekejap, mana? Dah submit?
Dah
Oh,
dah.
Amirul Is it this one? Oh, why negative
Yes,
ni?
madam.
Sekejap, apa ya? Let me see why. Maybe on the calculation side. 50. Betul? This one. Oh, because of this. Your V2 minus V delta equal to V delta divided by 5. Tapi betul lah. You put a V2 kan? Betul. Kejap, betul. Maybe only on the equation code yang salah. This is 5 V2 betul. Betul. This part. $50 minus V2 betul. 390 V2 and minus betul 7.8 ni dengan 2.6 betul. Oh, the 390 you should put negative. This part. Can you see I highlight something?
Okay, I notice, madam. Sorry, madam.
Yeah, negative, and everything will be okay. Okay, thank you. Any other suggestion or you want to ask me something? Or you don't like this way? Do you like our class to be like this? Please upload your answer. This one will be counted as your attendance. And I'm still confused why we have only 35 plus 19. Okay, got kita pun. Okay, with that, no question? Any question? Or you want to write down any suggestion? No?
Madam,
Yes. Okay.
kalau tak siap tu kena submit juga ke?
Submit je.
Okay. Alright, madam.
Okay. Because that one has your attendance. Tapi minta maaf ya, I will not check all your answers. Any yang betul aja tadi dapat. Tapi itu dah. Okay, with that we finish our class with tasbih, kafarah and surat al-as. Subhanakallahumma